I want to prepare you for probably the most difficult section in this whole class. A lot of people have trouble with linear programming. Basically, it's using more than one inequality graph at the same time. So hence the term systems of linear inequalities. Okay, or you call them shade graphs. Now, more than one, why would we have more than one? Because at the same time, you may want to keep your profit above a certain amount, or maybe your inventory above a certain amount, but at the same time, you want to keep your taxes below a certain amount. And where those two shade graphs meet will be the area in which you want to stay in your business. Okay, and that's what we're approaching, the idea. But let's look at it from a graphical point of view and practice what we did before. Okay, let's try and graph this system. We'll do one at a time, that's all. The first one, we're going to solve for y, just like we did last class. So we'll subtract 2x from both sides. And then let's see, what's keeping y from being alone? The 2. So we'll divide everybody by 2. And we didn't divide by a negative, so we won't switch the sign. So now we have y is less than or equal to 4 minus x. And y is by itself, and we can make a little chart like we did before. This is all, you've done this before. And there's no fraction, so I'm just going to put in the easiest numbers I know. Let's see, 4 minus 0, so y would equal 4. And what's the next easiest number? 1. Okay, 4 minus 1 would be 3, and I'll graph that point as well, over 1 and up 3. Okay, I like to do 3 points just in case to make sure they line up. So we'll do one more x value, we'll do 2, and let's see, 4 minus 2, y will be 4 minus 2, which is 2. Now let's see if the point 2, 2 lines up. I start at the origin and go over 2 and up 2, and there's our boy. Okay, it looks like they line up. So let's draw this. Now, this one, hopefully you appreciate, since it's a less than or equal to, it's going to be a solid line. And since it's less than, we'll shade below that line. Now we're already halfway done the problem. Okay, we graphed the first inequality equation. Now, let's do the second one on the same graph now. Let's see, again, we have to solve for y. So I'll subtract 4x from both sides. And now I'm going to have to divide by negative 2. Now remember, when you divide by a negative number, you have to flip the sign. So I flipped it to y is less than or equal to 2x. Now negative 4 divided by negative 2 is a positive 2x, right? Okay, so again, we got y by itself. Let's make a chart and put in some easy numbers. I'll put in 0, and I'm going to pretend y equals 2x, so y equals 2 times 0. 2 times 0 is 0, so let's graph the point 0, 0. Okay, and then we'll put in the number 1, and 2 times 1 is 2. So I'll graph the point 1, 2, go over 1 and up 2. And finally, like I say, I like to do 3 of them to make sure they line up. Putting in a 2 for x, I get y equals 2 times 2, or y equals 4. So I go over 2 and up 4. And son of a gun, they line up. Now, is this going to be a solid line or a dotted line? It is or equal to, less than or equal to, so it's going to be a solid line. And we shade below that line because y is less. Okay, so what we're looking at now is the system, the answer or solution to this system, you see, is going to be where those two shade graphs overlap, or the intersection. So that answer is going to be right here. Hopefully you can see. Now that answer, hopefully you appreciate, is going to go on forever. So we're going to use a fancy word here. We're going to say that's unbounded. It doesn't end. It's unbounded. Okay, I'll show you in the next example, I'll show you one that is bounded. Okay? So that's the idea. It doesn't get too much harder than that. And we can actually do that with a calculator. Now, before we can do it with a calculator, we're going to have to do what we did before. We're going to have to solve for y. That's another reason. Notice the very first button on the calculator is the y equals button. So again, I'm not going to take the time, but I'm going to solve those both for y. Now let's look at the buttons that we're going to use. We're going to use the y equals button. Okay? These are the cursor buttons. Okay? The enter button. And then once I have everything right, I'm going to use the graph button. Okay, let me show you how I'm going to do these. Now I brought up my TI-83 Plus calculator. Let me turn that baby on. And as you can see, I've already solved for y in this blue equation. So I'm going to hit the y equals button. There it is right there. And I'm going to type what y equals. 4 minus, and here's the x button right here. Okay? Now, if I hit graph, you'll see that it's only going to be the line, and that's not what I want. I'm going to go back to y equals, and notice this little line right here. I can actually cursor over and sit on that. Right now it's set to the line. But if I hit the enter button's right here, I can move through various, that's the thick line, various options. That's above, and that's below. I'm going to leave it on below, and now hit graph, and see again, it's going to look a little different. Now it's going to shade below. Just for laughs, let's see what it would look like if I shade above. So I'll hit y equals, cursor back over to it, and I rotate through using the enter button. Keep going. That's a dotted line. Okay, there's above. And I'll graph. As you can see, that's what above looks like. Okay? But we'll switch it back to below. So y equals, cursor over. Okay, I hit enter to get it to the below. Okay? Now, as you can see, I have the below. Now I have to put in this other equation, y is less than or equal to 2x. So again, I want it on the same graph, so I hit y equals, but I don't want to put it here and overwrite the 4 minus x. So I'm going to cursor down. See how I'm sitting there? I cursor down. And I can do up to 7 of these at a time. How cool is that? And I'll put 2x. There's the x button. Now, what do I want for this one? This one, again, I want the less than. So I'm going to cursor over and hit enter until I get the less than triangle. That's the above. There's the less than. Wait till you see this. Okay, oh, and it does them both. And of course, where they intersect, as we showed you before, is the solution to this system. And we could do all kinds of other ones on the graph as well. And we'd see where they intersect. So that's pretty cool. Anyway, let's try another example. That's how to do it with a calculator. Let's do a couple more examples of systems, because there's other things that can happen. Okay, let's look at another example that's going to have a couple new concepts for you. This one's going to have 3 equations. So we'll have 3 shade graphs, if you will, on the same graph. And often you're going to find out in our next section, you're going to want things to never be negative. You don't want your, I don't know, your profit, you always want to be greater than 0, or your inventory, it can be 0, but it has to be more than 0. Can't be negative is the idea. So this is going to be a very common thing to do. We had done that in the last section, graphing y constants, but let's do it again, and we'll do a couple at a time. Well, let's do the first one. We're going to solve for y like we did before, subtract 4x from both sides, and I guess in this case we'll have to divide by 3 to everybody. Now in this case, dividing by 3, we're going to get a fraction. Now, do you remember what you do with a fraction? Whenever there's a fraction, it's going to make life easier. You get to put in whatever x you want. We're not going to put in 0, 1, and 2 this time. We're going to put in multiples of 3 so that it'll cancel out. Now, I'm going to use 0. I always use 0, okay? And 4 minus 4 times 0 over 3, I end up with 4, okay? It's basically 4 minus 0. So I graph the point 0, 4, over none, and up 4. Now, the next value is key. I'm going to put in a 3. Now, if I put in a 3, you see, that 3 is going to cancel, and I'll end up with 4 minus 4, which is 0. So I'll get the point 3, 0. So I'll go over 3 and up none. Now, I could put in 6, but it's not going to fit on this graph very well. So I'm going to put in negative 3. If I put in negative 3, I have 4 minus 4 times negative 3 ends up being 4 plus 12 over 3, or 4 plus 4, or 8. So I get the point negative 3, 8. So I go back 3 from the origin and up 8, and it ends up being up here. But at least they line up, so I know I'm okay. Now, once again, let's remember this is going to be a less than or equal to. So it's most of these are or equal to's. So it'll be a solid line, and since it's less than, we shade below. Now, that's pretty much the same thing we did before. Let's look at this middle one, though. The y is greater than 0. It's already solved for y. So how do I do that? We're going to pretend y equals 0. Just pretend for now y equals 0 and make a chart. Now you can put anything you want in for x. So I'll put in the easiest one, 0. And of course, what does y end up? It said y is 0, so it's 0. Sometimes it's so easy it's hard. And I graph that point 0, 0. Now if I put in the point 1, you say, where do I put it? There's nowhere to put it. But remember what we're looking for. That what is y? Well, told you. As I said, sometimes it's so easy it's hard. Y is 0, so it's 0. Just always 0. So the point over 1 and up 0 would go there. And I hope you guessed that if I put in 2, I can't really put it in, y will be 0 again. And this is why I want to feel comfortable with this. This is why I do 3 points. If I go over 2 and up none, I can see that I'm right. I can see that they're lining up. So I'll draw, in this case, a solid line, because it's or equal to. Did a green line there. And where does y get bigger? I need to shade above. Okay, do you see where the purple meets the green? That's going to be the intersection, at least so far. I still have one other one to do. I still have this third one. X is greater than or equal to 0. We want x to be positive. So I pretend x equals 0, and much like the other one, I'm going to put in points. But in this case, I don't get a choice for x, you may recall from our previous graphs in the last section. I don't get a choice. X has to be 0 every time. Didn't say anything about y. So y can be anything. So when it can be anything, I'll make it 0. I'll have the point 0, 0. I make it 1. Okay, but as long as x is 0, and the point 0, 1, now let's see, go over none and up 1. And the point 0, 2, go over none and up 2. And I see that, again, they line up. I guess I'm okay. And I'll draw a solid line. Now be careful here. Where does, because we want x to be bigger than 0. Okay, where does x get positive? It gets positive to the right. Okay? Or it gets bigger to the right. There is no above or below in this case. So, there's your 3. What section is brown and purple and green? that would be the solution, we call it the solution, graphical solution to the system. And that is the area right here. Now that area, we're going to use a fancy word again, that's not unbounded. It ends, okay? It's bounded. It's limited, okay? You can see it, and that's going to be of great use to us in the next section. So hopefully you can see it doesn't go on forever. It stops, and it's a shape. And that's the idea. Okay, let's do one more example. Now this one has 4 equations. We can do it. Note that it's going to be very common to have the last 2, y greater than or equal to 0 and x greater than or equal to 0. We might as well get good at that. Okay, it's going to be good practice because they're almost going to be there all the time. You want positive values in business for many concepts. Okay, so let's start with the first one. We'll solve for y. We'll subtract 2x from both sides. And we already have y by itself. Gotta love it. So we're going to go a little faster this time since you've already done this. Let's make a chart. We don't have any fractions, so we can put in 0, 1, and 2. I'll put in 0. And 8 minus 2 times 0 is 8 minus 0. So it's 8. So let's graph the point 0, 8. And there she blows. Now let's put in 1. And 8 minus 2 times 1 is the same as 8 minus 2, which is 6. So the point 1, 6 over 1 and up 6 from the origin. Finally, if I put in 2, 8 minus 2 times 2. 8 minus 2 times 2 is 8 minus 4. 8 minus 4 is 4. So I'll go over 2 and up 4. And son of a gun, they do line up. So I'll draw a solid line in this case and shade, it's less than, below. Okay, there's one. Now let's look at the next one. Solve it for y, so subtract x from both sides, and we get y is less than or equal to 6 minus x. So again, we'll put in 0, 1, and 2. 6 minus 0 is 6. So the point 0, 6, go over none and up 6. Put in 1. 6 minus 1 is 5. So over 1 and up 5. Okay. And finally, put in a 2. 6 minus 2 is 4. So over 2 and up 4, and they line up real nice. So it looks like we're going to draw, again, based on this symbol, a solid line, and I'll shade, be careful where they, see if you can see where they cross. Well, shade below. Okay, what's both gray and orange? Okay, we can see that there's a lot of it is. We can go on forever there. Now, we still got to include, that's unbounded at this point, I hope you appreciate. So let's do our y is greater than or equal to 0 part. We pretend y equals 0. And remember how simple this is. You can put in anything you want as long as y equals 0. So I'll put in 0 and y will equal 0. It just so happens that x equals 0, and I'll graph that point. If I put in 1, once again, y equals 0. The point over 1 and up none. And finally, 2, the point over 2 and up none, goes right here. I shade above because it's y is greater than. This time I shade above, don't I? It's a solid line, and I draw the line and shade above. Oh my, where do they all cross? Let's see. Finally, let's look at the x line and pretend x equals 0. As long as x equals 0, we're okay. 0, 0. And I'm going to put in another point for y. Put anything I want for y as long as x equals 0. The point 0, 1, over none and up 1. And put in one more y value, 2. And I'll have 0, 2. So I go over none and up 2. And I'm feeling pretty good once again because they line up. And I'll draw the line. Now be careful. Where does x get bigger? X gets bigger to the right. So where do they all cross? I hope you can see where they all cross. It's kind of tough. The solution to this system is this area right here. And in this case, it doesn't go on forever, does it? So what's the word we use? We say it's bounded. Okay? And in the next section, I'm going to ask you to find the corners of, now the one corner is easy, 0, 0, for instance. But I'm going to ask you to find the corners, and you should be able to do that by using the substitution method, and we'll show you how to do that. Okay, but for now, your homework's just going to be doing more than one shade graph on the same coordinate plane. Okay? Well, go do it.